So we've talked about the product rule, so now we've talked about the sum and the difference and the product of functions, of derivatives. Now let's talk about the quotient of derivatives, talking about division now. This one's a little more tricky. There's just a little more moving parts. These are still functions u and v, but there's a specific order this time to the way that it works. So it works like this. V times u prime minus u times v prime, all divided by v squared. And again, I'm not going to show the derivation for these formulas. They involve the limit definition. They're cumbersome, and frankly, it's more than you guys need to know. So here is my my quotient rule formula. And we've kind of developed this little kind of sing-songy thing to remember it. And if I call this just, come on, put the color here. If I call this just maybe the lower function, and maybe this one the higher function, well, then it turns out that I'm taking low times the derivative d high minus the high function, the derivative d low, and it's divided by the square of the low function. So what we wind up having is this low d high minus high d low, high d low. We're going to divide by the square of what's below, and that's kind of where it comes from, right? Divide by the square of what's below. And so it turns into this low d high d low, divide by the square of what's below. Kind of this little sing-song thing. But it gets stuck in your head, and it really helps you remember it. It's also on your formula sheet, so that's helpful too. But let's take a look at some examples. So low d high d low divided by the square of what's below. Let's practice it. So again, it helps to establish u and v and do your side work just as we talked about with the product rule. So I'm going to call my high function u and my low function v, and I'm going to do some side work. So let's find u is 1, so the derivative is 0, which is a constant. And then v is 2x plus 3, and the derivative of that is just 2. Derivative of a constant is 0, and all of that. I'm going to copy and paste this again just so I can save myself some time here. And we can take the derivative using our quotient rule. So let's do that. So low d high, which is just 0, minus high d low. Whoops, d low is just 2. Divide by the square of what's below. So just take v squared. And normally, honestly, we wouldn't really simplify that denominator, but we are going to simplify the numerator a bit. And so I get negative 2 over 2x plus 3 squared. The only time I would really consider squaring the denominator and actually expanding that is if I thought I had some reason to actually do that. So if I thought I had some reason to actually make a cancellation, then I would think about it. But I don't really need to, so I'm not gonna. Let's take a look at another example. Low d high d low. Let's try it. So we have a quotient. We're going to use our quotient rule. So again, let's define u and v. So u is 2x squared plus 3x. So the derivative, I'm just going to use the power rule again. I'm going to have 4x plus 3. And v, keep my colors the same. V is 3x cubed plus 1. And so v prime is 9x squared. Again, just using the power rule. Let's apply our quotient rule. Again, it's always helpful to start by copying it down. Copy it down in general and then apply it. This way there's no question as to what goes where. So I get low d high minus high d low. High d low divide by the square of what's below. So 3x cubed plus 1 squared. Again, we should maybe take some time and simplify this. So again, we're not going to really pay attention much to the denominator unless we really think we have a good reason, that's not the color I want, to do that. So I'm just going to take a second and simplify this kind of on the side. So if I do some FOIL in here, I've got 12x to the 4th plus 9x cubed plus 4x plus 3 minus, let's see, 18x to the 4th minus 27x cubed. So this is going to give me negative 6, yep, negative 6x to the 4th minus 18x cubed plus 4x plus 3. And that's, I don't know what it's going to factor into, but I know it's definitely not going to factor into 3x cubed plus 1 squared. So I'm not going to bother going any further with this. I'm just going to leave it as is. So really, as long as we can just condense my expression into a polynomial and then that binomial on the bottom, or whatever the squared thing is on the bottom, that's more than enough. So quotient rule. So now we've talked about sum, difference, product, and quotient.